Alright guys, welcome to this page of the notes. What we're doing is we are graphing systems of inequalities, and I have given you one here. Now this looks slightly different than the ones that we have tried before because I have now given you one of those special functions we learned about back in chapter 2. Remember, those special functions were the absolute value function, which I've given you here, the quadratic function, the identity function, the constant function, and I'm forgetting one. Was it the greatest integer function. So this is the absolute value function, and hopefully you should remember from chapter 2 that when you graph an absolute value, it looks like a V. That V could be opening up, that V could be opening down. And if you don't remember any of that, just head on back to chapter 2. Actually, I believe that you can find that in chapter 2, section 7. Section 7 is where you're going to find absolute value. But anyway, nonetheless, we have an absolute value. So let's assume that you remember how to do this, and here we go. We're going to graph y equals the absolute value of x, and I need it to be a solid line. Alright, well, we know that the absolute value of x looks like this. Since there are no transformations performed to it, I don't have an a, an h, or a k. This is actually just the parent function, which means the vertex of the absolute value is at 0, 0, and it is a v opening up. Solid line. I think what's getting me in trouble is when I turn my iPad, so let's not do that. Nope, that's not much better, but whatever, we'll take it. All right, so there's my absolute value. Step 3. Okay, careful. It goes through 0, 0, right? My vertex is at 0, 0. So I can't use 0, 0. This is going to be one of the instances where 0, 0 does not work. So let's pick something easy. What if we went with 0? 0, 1. That would be a point just inside of the absolute value graph. I like it. We'll go 0, 1. That's even better. Nice point. So I'm going to do y is greater than or equal to the absolute value of x, which means 0. No. All right, hold up. It's xy, not yx. Sorry. The value of y is 1. So 1 is greater than or equal to the absolute value of 0, which means 1 is greater than or equal to 0. Okay, is 1 greater than or equal to 0? Yes, it is. That is true. All right, well, since my test point, which was inside of the V, it's a point inside the V, it's 0, 1, so I'm just inside the V, and it gave me a true statement. That means I shade everybody inside of the V. That'd be everybody shaded in. Cool. This one. Graph this one in green. 5, 1, 2, 3, 4, 5. It's 4 thirds. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And it's a dotted line, so we're going to run right straight up through there, like that. Okay, great. So, sorry, I didn't write it down, but it is a dotted line because of the strictly less than sign. Step 3, can I choose 0, 0? Well, for this one, I can. My green line doesn't go through 0, 0, so now let's plug that in. I get 0 less than 4 thirds times 0 plus 5, which means 0. Is less than 5. That's a true statement as well. My test point was right here at 0, 0, so I would shade everything on this side. And that means it looks like my solution region, if I go ahead and use my highlighter, is going to be everybody right in here. That appears to be where the green and the red overlap, solution region. Let's try another one. How about we do, yeah, there's one for you. Okay, typical inequalities, and I've actually already solved them for y for you, so we'll just run through these real quick here. Let's see what this looks like. I'm going to first graph the equation. Y equals negative 4x plus 8. All right, let's do that. 1, 2, 3, 4, 5, 6, 7, 8. Negative 4 over, let's see, negative 4 over 1, so down 4 over 1. Awesome. Now I need I need a solid line. I need a test point, and 0, 0 is going to work. Sorry, I'm standing in front of the graph. I apologize. I'm so sorry about that. Again, my y-intercept is 8. My slope is negative 4 over 1. Negative 4 over 1. Solid line. It doesn't go through 0, 0, so I can use 0, 0, and 4. I'll have 0 greater than or equal to negative 0 plus 8. Which means that we wind up with 0 is greater than or equal to 8. That's false. That's not true. So we shade the opposite side of the test point. All right. This one. We can do that. Let's do it in green. One, two, three, 4. I have a slope of negative 4. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. All right, hopefully what you recognize here is that I have two lines with the slope negative 4, negative 4, and different y-intercepts. These lines are parallel. So when I go ahead and draw this line, which is going to actually be a dotted line, which runs right straight down through here, what I find is that those lines actually don't intersect. They'll never intersect each other. They are parallel lines. But now the question is, where do I shade for the green line? Well, let's take a look at it. Let's see, 3. I can definitely pick 0, 0. And step 4, let's plug that in. So I have 0 is less than negative 4 times 0 plus 4, which means 0 is less than 4. That is true. Which means I shade everybody on this side. All right, awesome. So here's what happens. For my red line, I'm shading everybody to the right. For my green line, I'm shading everybody to the left. My only possible solution region would be everybody between the two lines, and that doesn't happen since the green goes to the left and the red goes to the right. Those two solution regions never overlap, and so we wind up with no solution, because the solution regions don't overlap. Okay, that takes care of this first objective where we are graphing inequality, systems of inequalities. The second objective was finding the vertices of a system of inequalities that when you graph them form a geometric shape. So if you head on over to the next page of the notes, we'll take a look at a couple of those, and I'll meet you there.